Okay, let's go do this again. Hi guys, and it's day 4 of January 2025. As we check that, I do quite a bit during the day, so I lose track. Being that I haven't been working, which I go back to work on Monday, which is 2 days away. This is Saturday, so yeah, I go back to work on Monday, which is Monday the 6th, and go back to doing some steel fabrication work, which will then reset my clock into working daytime, and knowing the days, Monday to Friday, Saturday, Sunday. The past year or so, I've had trouble keeping up with that because I don't have any set work days anymore at this time, which is causing a bit of problem. I need to set that so I can make things work again properly. So, yeah, what I want to do is have a chat and do a chat on my thoughts on quantum fields. Quantum fields. For those who are into quantum theory, quantum physics, quantum mechanics, and quantum field theory, remember it's a theory. It doesn't exist. It's a quantum field theory. Okay, there's nothing that does exist on that at this stage. It's still only a theory. All right, just like everything else on the planet that we do. While it's a theory, it's just as good as what I'm saying as what anybody else is saying as to anything else. I'm into ether and etheric fields, okay, which I can evaluate and confirm far easier than I can do with a quantum field. How does one make or quantize a field? Of course, you can do what the quantum mechanics guys or quantum theory guys do, and which they do all the time. We'll come up with an imaginary thing we'll call, what do we call them? Gravitons? Let's start there. Or we'll do, I don't know, whatever they want to use as particles to put in this field. A quantum field particle. Like, how do you get a particle in a field? How do you make a field make a particle? Well, how do you make a particle make a field? Okay, you can use one to induce the other. You can have fields induced by particles, because fields in most cases is a wave of some sort. It's a wave of energy. So I can get lots of particles, like a big rock, throw it into a dam, and I will impart the energy of that rock and its mass into the water in that dam, and I'll make waves which will go out in all directions from there. And I can say, well, okay, those particles made that wave, but there's no particles in the wave. Okay, you got to remember that. Just because the particles made the wave, they didn't put themselves into the wave. But of course, that wave has no particles in it, and that wave will keep on going across the dam until it hits the beach. And then it will impart the energy it has in those waves into the particles on the beach. So then you have particles in the wave, because just like the particles on a dumper on the beach, all of a sudden the sand comes up and is churned all over the place, and you have particles in the wave, but only on the beach. All right, as soon as that wave goes away, all those particles settle down to the bottom, and they're no longer particles in a wave, and that wave is gone, it's dissipated. All right, so how do you quantize a wave? You have a wave of energy, like a wave of sunlight energy from the sun, a wave of energy from the sun. We call it sunlight when we see it, but of course you can't see it until it hits particles. While there's no particles, you cannot see the wave. You cannot see the energy coming from the sun coming to Earth. You can't see it till it hits something and then reflects, and those particles are scattered all over the place. Like, okay, you'll see it in a grain of dust as it's flying through space, and you'll happen to be in the right place at the right time to see that energy that has been imparted into those particles reflect or make light that you can then see, because it ricochets off that particle and sends that energy wave into your eyes, which then moves more particles in your eyes so you can acknowledge you're seeing it. But at no time are there any particles, in 99% of cases, coming from the sun to that particle, or from that particle to your eye. All right? It's near impossible. Yes, you do have particles coming from the sun in a sense of a matter wave, which comes a lot slower than energy. Energy travels at supposedly the speed of light, whatever that may be. Okay, since we can't travel at that speed and make that happen, we've still got some things to learn there yet. Just like learning about the speed of sound. When we knew about that, before we knew about that, okay, people thought we'd burn, physically vaporize as we get to the speed of sound. That was back before 1930. Then, once we started breaking the speed of sound, that all changed. Now, we have the same thing coming for the speed of light. Okay, we know so much about the so-called speed of light, but yet we know nothing because we have not surpassed the speed of light. So until we pass it, we cannot understand it completely. Understand? Probably not. But it will happen, and it's going to happen awfully quick, because we are doing things in leaps and bounds right now as we surpass all our knowledge from the past, and slowly, piece by piece, the knowledge we have had in the last 100 years is being allowed to be perceived again. The works of Nikola Tesla, for example. Do you realize we're only using 10% of what that man came up with? We're not allowed to know the rest. They've kept it all top secret. Okay? There's so much out there that we have not been allowed to use in the mainstream. Yes, you get into places like where Elon Musk is playing, and I know from the way that we hear the videos made about Elon and his efforts in space and his team. You've got to remember, whenever we talk about Elon, we're not just talking about Elon. You're talking about a huge team of people, okay, a massive team of people in every field he's in that are helping to make it happen. Elon's just the instigator. He's the man who's holding it together, the man who's being blamed for everything, okay? And he is the how do you put it? He's the hub. Okay, I've been in the same place holding groups together. He is the hub that holds the whole thing together. Okay, whether you like the hub or not, it's wrong colour, wrong shape, doesn't matter. He is this hub for SpaceX, Tesla, Boring Company, all his things, pies he's got his fingers in. He is the main hub that it all circulates around. Okay, he is the star in that solar system of all his companies, and everything moves around him, with him, for him, and all those wonderful people that are working for him and are doing things on the sidelines. And many, well, almost all, do it without any pats on the back or anything. Okay, I'm sure Elon gets around there and pats as many as he can on the back, and I'm sure it's quite a few of his team goes around and pats other guys on the back to say, thank you, you've done a great job, fantastic, this is great. So, yes, Elon's the hub, and it all centres around there, and of course, he's the one that the media, the dead shits that are trying to blame him for everything that's wrong, all the stuff that's happening that we hear about Elon. Like, to have that man out there, to be on the cusp, to be right at the edge, and I know what it feels like, I've been there before. anybody that's ever been on the edge of their field knows it's not easy being there. And there's only a couple of people that are capable of handling the stress, the pressure, the speed it travels at, and all the other weird, wonderful things that happen while you're there. Okay? And it's only because of your team behind you that you're able to succeed at where you are, because they're the ones holding you out there. They've got you by the hands and legs. If you can imagine grabbing someone who's trying to pretend they're as stiff as a board, you've got two guys holding, one hand each, another two strong guys holding the feet, and then pushing you out, just like you see in some show of some sort, where they're doing calisthenics or whatever, some sort of sport, and they're shoving you out, and you're sticking yourself out into the front, and these four guys are holding you back to hold you up as you balance without bending your body to keep forward, almost level, as they hold you out there, and then drag you back, and they push you back out, pull you back, push you back. That is how living on the cusp feels like. It's just like that. You're stuck out there, and whatever comes, you're going to cop it. And hopefully you're strong enough to handle it. If you're not, hopefully the people behind you are able to help you take the pressure, heal the wounds, and then summarily shove you back into the gravel. Okay? But anyway, we're drifting away from where we were supposed to be, which is quantum field. Quantum field theory, quantum field effects, quantum field bullshit. Okay? To be able to quantize anything, you first need quanta, particles. You need something you can quantize. Okay, whether you've got a bag of apples, you need to know there's, 20 apples in the bag. So you have 20 apples. That is your particles that you can count. All right? The gravel on the beach, when the wave hits it, those particles that are scooped up and circulating inside that wave, they're your quantized particles. You can count those. You can then quantize that field and work out that field that's hitting that beach is doing this fantastic thing. But the actual field itself that's making all that happen, you can't do a damn thing about it. Okay, you can only see what's happening and state through your quantum field theory what you think is happening right at that instant in time. But the quantum field changes every millisecond. Okay, and there's no way without understanding what a field is and how it works as to whether you can quantize anything except for that particular instant, millisecond in time in front of you. Because as soon as that instant's gone, you've lost it. It's no longer there. All right, those particles will fall into the ground and forget it. Your theory is all bullshit. It's gone again. Okay? And the next time that the next wave hits, it's a totally different wave. So you cannot say with any exact measurement that that's what's going to happen, because that's what happened last time. But the wave that's coming isn't as big as the one that was just there. It's like tidal waves. They're all different sizes when they come in. Okay, one on the back of the other one. So you see it on the tidal waves that hit Japan 11 years ago, 12 years ago. There was one wave that came in, and then another wave that crawled up over the top of it, another wave that crawled up over the top of that, and another one that crawled up over the top of that. You try and quantize that. Okay? First come up with the particles. Okay, there's no particles. And then you say, you'll say, but the ocean's particles. Okay, well, let's have a look at quantum fields on a tidal wave. Let's imagine that there's a tidal wave that starts via an earthquake happening just the east coast of Japan. Okay, similar to what happened 12 years ago, 11 years ago. Let's say that happens, a giant movement in the ground underneath the ocean, and bang, we have a wave. Now that wave right there, okay, at the very instant it was made, may have leapt out of the ocean, what, 6 feet? If you're lucky. Most of that wave is still in the ocean. You can't see it. It's just energy that has been imparted into the ocean. Now, have you ever run your hand through when you're in a swimming pool, run your hand through the water? Have you ever moved the water? Or do you just move your hand through it? All right? You move a little bit of water and you move your hand a lot. But at no stage do any of the particles that you moved in that pool make it to the other side of the pool. They don't even move away from where you are. Okay, most of them actually go past your fingers, past your hand, come around the other side, and virtually don't go anywhere. Same with the wave in the ocean. The tidal wave starts in Japan, bang, moves both directions away. One goes to Japan, the other one heads over to California. All right? As it flows over to California, how many particles from Japan are in that wave? You tell me that. How many particles are in that wave? Okay, whether it ends up at Canada or anywhere across the west coast of America, it'll end up there somewhere. How many particles from Japan are in that wave when it hits the west coast of America? Okay, if you say there are any, you're wrong. You can get a boat directly over the top of that wave, directly over the top of where that wave was made. Flies. So directly over the top of where that wave was made, and see if that boat goes anywhere except up and down. All right? A wave has amplitude. It has a frequency. Because once that wave, the rock goes up and down, the wave goes up and down, and it just generates a frequency of so many waves per second or minute, whatever. Okay, depending on what you're operating at. If you're operating at light frequency, okay, you've got many waves per second. If you've got a wave going across the ocean, tidal wave, you probably got a wave, one wave a second, one wave, I don't know, might be one wave a minute, depending on how long those waves are. So, but either way, you have amplitude and frequency. You also have how much energy is imparted into that wave. Okay, so as we move, that wave has energy. Now, that tidal wave, in most cases, this is why we've got all these buoys all over the ocean to try and tell us there is a wave. That wave possibly moves a buoy near where the wave was created 6 inches. Okay, maybe a foot. All right, ocean waves, of course, they're up and down all over the place, but the actual tidal wave itself hasn't gone anywhere. It's hardly moved anything. But as it goes and flows through the ocean, that wave is imparting energy into particles that are in the ocean, like the fish, the dirt, the plastic, whatever's in there. But that only lasts for that instant it passes past those particles. Okay, if you're in a submarine and a tidal wave goes past you, I doubt if you even know it exists. All right, it's not going to do much. All right, it may move. I don't know. You may feel the boat move an inch or two forward and an inch or two back as the wave goes past you. That's about all you can get because it's only a wave. Okay, it's not particles. It's not like a rock's coming and hitting the side of the boat. There's nothing in it. There's no particles in it. All right, there are particles that make up the wave because it's the ocean. Okay, if you're in space, it's a whole different ballgame. There's nothing there. All right, but if the wave is traveling through the ocean, as energy waves do, they travel through everything. They travel through rock. They travel through space. They travel through the sun. They travel through everything. They travel through you and me. These energy waves, I'm getting confused here. These energy waves travel through everything. Now, in the old days, we'd call this the ether because these waves exist in the ether. They exist everywhere. All right? Etheric energy is everywhere. But let's not get onto that yet. Let's stay with the wave in the ocean, and I forgot to manipulate this thing. Sorry, my computer just closed down the screen. Give me a second. As I punch in the, yeah, there we are, back again. Punch in the password so the screen lights up and I can see who I'm talking to myself. It's an experience and a half. But, you know, these waves, I've got to make sure I keep on moving the mouse or doing something to keep the screen open. These waves are then moving towards the west coast. Now, the energy and amplitude, and frequency of that wave is the same from the time it left Japan to the time it comes close to the beach. Okay, as the land goes up and the ocean gets shallower, the water gets more shallow as the ground comes up, the wave amplitude gets higher, as we know. All right, the wave frequency can get faster because the ground slows the progression of the wave, and then of course the energy is still pushing, and you get more. The waves come closer, they shorten up, so your amplitude gets higher, and your frequency gets faster. All right, you understand that? I think I got it right. But the energy behind it is still there. It's still coming. All right, and that wave comes and comes and comes until it finally gets so far out of the water that it no longer can support its amplitude with all the water that's in it. Okay, if you're in space, it's a different matter. Until it hits something, you've got nothing. But in being, you've got water and gravity and all these things affecting the water, the wave comes up and then collapses. When it collapses, of course, it then starts imparting that energy, and only then does it start imparting the energy of that wave into the particles of the ground it hits. Whatever it hits, whether it's a mountain, people, buildings, cities, cars, buses, whatever it hits. You know, the fish are hardly moved at all. They're still swimming through the wave. If you've ever seen a wave on the coast, we see it all the time on the Gold Coast. You probably see it over in California too. You get a nice big wave. Quite often you see sharks swimming or dolphins swimming through the wave. They don't even know they're in a wave. All right, they're just swimming through the water, just gently swimming through the water, having a good time. All right, and they don't even follow it to the beach because they're not in the dumper. They got common sense. They know stay out of that. All right, that's past them. That's as it goes up. So yes, as it goes up and then dumps onto the beach, then you have particles galore. Okay, lots and lots and lots of particles. But until you have none, you have nothing. So this wonderful thing called quantum field, quantum field theory. Where? Please, look, comment on the video, please. Give it a like, give it a down, whatever you want to do. Just do something. Become part of this. I want to know what a quantum field is. All right? From my understanding, a quantum field is the way that with quantum theory, they can express ether. Because they don't want to say ether. Because as soon as they say ether, everybody in their field tells them to go, you know what? All right? Because they don't want to lose funding. They don't want to lose the following of the quantum field or the quantum theory guys all over the world that have been trying to suppress etheric physics for the last 100 years. All right, ever since the silly fools tried to debunk the ether. All right, and didn't do it correctly, didn't know what they were doing because they never did it before, so how would they know? All right. But they tried to use so-called common sense in the scientific field to express or to find out whether the ether exists. Well, we know it exists because if it didn't exist, you wouldn't have electricity right now. Okay? And no matter what you try and do with quantum theory, you will never ever make an electric motor that works. You can express what an electric motor is now that you've had it for 100 years, and you can describe how it all works, and you can make it better through your mathematics, but there are no particles within that alternator moving from one part of the alternator to the other. Okay, it's all electromagnetic field. You know, from your stator to your rotor, there are no particles going between each other. Okay, so tell me about quantum field, please. Let me know what your ideas are about quantum field theory and how it works, because I don't see it. You know, all I see is the ether. Energy exists in the ether. You know, we can go through the ether with astral travel, astral plane, astral world. We go through the ether with time. We made time by making matter. In the astral plane, and we had energy and thought. Okay, thought is able to utilize and manipulate energy. Through the manipulation of energy with thought, we made matter. By making matter, we then had time. Without time, you can't do anything. Okay, we have not learned how to do things without time. Time is a process of recording, of seeing something move from one place to another. It takes time. Without time, it doesn't happen. All right, when we finally get around to so-called warp drive spaceships, time from the time you leave this particular area here and jump to another particular area, time virtually doesn't exist. All right, so you're jumping time. You're jumping through your matter universe from one point to another by folding space. So that's a whole lot to learn yet. Let's just stay with quantum field theory. Show me, tell me. Let's discuss this. Try and understand where these guys get it. It took me 60 years, well, 50 years, 55 years to, yeah, good 50 years, I'm 65 now. It took me 50 years after reading half the book of Niels Bohr's quantum theory to finally understand the last half of it. Okay, I finally understood what quanta was, how they came up with quanta, what it actually does. Quanta, of course, quantum theory is the explanation of 1% of the universe. That's all it is. 99% of the universe is explained through ether. Quanta and quantum theory, quantum mechanics, quantum physics is all about that 1%. If that's probably only 0.1%, that is matter. No such thing as dark matter. That doesn't exist. It's called black. it's just nothing. Nothing exists there. That's why it's black. You can't see light because there's no particles there to reflect it for you. It's empty space. That's why they call it dark. They can't see through it. Can't see it. Okay. Of course, if there's no light, any particle, any matter that is in that dark area, you can't see. So that's possibly what they're trying to call dark matter, because they supposedly can't see through it. That's because it's got matter in there that hasn't got any light showing it to you. Doesn't mean it's dark, it just means there's no light to light it up. Okay, and if there is, it's so far away you can't see it anyway. So, yeah, that's quantum field theory. Please, let me know what it's all about. I want to hear from you. Thanks, guys. Talk to you again soon. Let's see if we can turn this thing on. Okay, love yous. Talk soon. Bye.